Good morning, all. So, we are solving now problem number 3 from the question bank VTU of engineering visualization. So, in this problem, we have to construct a pentagonal prism and we have to have a through hole in it. Okay, first I'm going to construct the orthographic top view of the pentagon, because we know that for the polygons such as a triangle, pentagon, and hexagon, you have to draw the orthographic first. Okay. So I'm constructing a pentagon of dimension 30 mm. Okay, now I'm constructing a box for it. We know that using the box dimensions, we can able to construct the isometric view of it. So draw the box with respect to the extreme corner of the pentagons. So like this, you can construct the box for it. Now we can measure the dimensions of the box. So, okay, for easier understanding, I'll be giving the naming for this box such as 1 2 3 4, so that it will be convenient for construction. So we can mention 1 2 3 4 for the box naming. So draw an XY line. So now you draw an reference line. Okay, now using the box dimension, we can construct from 1 to 2, it is 46.17 and angle is 30 degree, and again length is 48.34, angle is 150, again length is 46.17, angle is 210 degree. And then you can join. So it is an rectangle. Okay, now we have to use arc by center command to cut the arcs here. So from 1 to 2, we have 28.53. So go to arc by center. In between 1 to 2, you can cut 28.53 radius. Okay, the same way from 4 to 3 also, that is your radius distance, 28.53. You can cut the arc. Then between from 2 to 3, you have to cut 24.27 radius, cut the arc. In between 1 and 4, we have to cut 9.27, that is from 4, by taking reference at 4, cut the arc for 9.27, and same way from 1 you can cut 9.27. Okay, now go to continuous line. Now join by zooming in to the exact points. Construct the pentagon with respect to the cutted arc point. Okay, now vertical height I am going to give from this pentagon corner points. So the length I'll give 50. So I'll go to move command, create a copy of it, select the end points and place it with the exact extreme corners. Okay, now construct another pentagon above it by joining these extreme points of the lines. So pentagonal prism it is constructed. Now we have to construct a through hole here. Through hole means hole will be in the shape of circle. So when it is constructed in the isometric, it will be seen as an ellipse here. Okay, first I am drawing the perpendicular bisectors to get the exact midpoint. Okay, so draw the perpendicular bisector from the corner point to the opposite point, midpoint. Okay. So here for constructing a ellipse, I am taking a length 30, angle will be 30, again length is 30, angle 150, and again length is 30, angle will be 210. So using 4 arc by center method, I am constructing the ellipse here. Go to arc by center and cut the arcs to this length. So subscribe for the channel, hit on the bell icon for the latest notifications, and share to maximum students so that they can benefit it from this. So here draw the diagonals and take the exact center point using move command. Midpoint you can take and then place it exactly to the center point here. I think for the top face center point not drawn properly, I'm going to delete it, and again I'm going to draw perpendicular bisectors. Now we have to join these two ellipses with their periphery. Yes, you have to select that particular point and draw straight line vertically downward. Okay, so this completes the problem. So select this final completed isometric. Show the angle 30 degree for the angle of inclinations. Select the entire diagram, go to scale command and type 0.816, enter. So this completes the problem. So pentagonal prism with through hole. Good morning all. So this is the question bank from VTU for engineering visualization subject. Okay, now we are solving the isometric problems. Okay, now I'm going to solve this problem number 4. Draw the isometric view of sphere radius dash mm resting centrally on top of a square prism dash mm side. So square prism first we have to construct. Okay, first I will take one reference line. From there I'll consider the base length 50 mm, angle 30 degree. Again length is 50, angle 150, again length is 50, angle is 210 degree, then join. Okay, so since it is a square prism, the height I will consider 60 mm, more than 50. Okay, if I take 50 it will become prism. So cube, to avoid that, so it is a square prism, the height I will be considering 60 mm. Okay. Okay, square prism is constructed now. So I'll be constructing it into ISO, because we know that sphere will be constructed with actual scale. Okay, so I'll show the angle between here. So go to scale and type 0.816, enter. Zero 0.816, enter. Okay, go to circle. Okay, from this center point, this is what the center of the sphere. Give the diameter 50. So we have completed. You can see that square prism completed with ISO and sphere completed with actual scale. So we will move to next problem. So in this problem, a rectangular pyramid of dimension 40 into 25, height 50 mm is placed centrally on a rectangular slab of sides 100 into 60 and thickness 20 mm. So draw the isometric projection of the combination. First, I'll be constructing a rectangular slab of 100 into 60 and I'll give thickness of 20. Okay, take a reference line. Okay, give the length 100 and take angle 30 degree. Again give the length 60, angle 150. Okay, again length 100, angle is 210. Then join. So give the height 20 mm, here thickness 20 mm. So give the length 20. Okay, go to copy, creates a copy, select the end point and place it exactly on the corner points. Select the bottom face, go to move command, creates a copy and place it. So rectangular slab is done. Now we have to construct an rectangular pyramid of dimension 40 into 25. So on the 100 mm side, I'll be cutting at 30 mm radius by taking 30. Okay, 100 minus 60 means you will get 40. So go to arc by center from the end point. So here we have to give 30. So give the radius 30. From this end also you can type 30. Okay, the other side it is 25. So 60 minus 25 means it is 35. So 35 means 15. So 15 means 7.5 we have to cut on either side. Okay. So this is we are constructing using subtraction of box method. Okay, now we got a rectangle of 40 by 25. So we'll join with the thick line. I will be drawing the two diagonals to find out the center of it. So from the center I will be drawing an axis line for a length of 50 mm. Vertically 50 mm I'll consider. Okay. Okay, so this completes the problem. You can show the 30-degree angle and select the entire isometric drawing and convert into ISO. So in the scale we have to give the value 0.816, enter. Okay, now we move on to next problem. So in this problem, a frustum of square pyramid of base side 40, top face side 20 and height 60 rest on the center of the top of a square block of side 60 mm into and height 20 mm. So first we have to construct a square block. Square block of 60 into 30, again 60 into 150, again 60 into 210 degree, and height we should consider 20 mm. Select the end point. Select the base, go to move command, creates a copy and place it. So we have completed the square block. Now frustum of the square pyramid, so base side 40 mm, and top face side 20 mm. By selecting the top face, okay, I'll be drawing the two mid lines to find out the center. Then after that I'll be selecting the top face. Okay, creates a copy. I'll go to scale and give 40 by 60. So because the top face we're having it 40 mm, base side 40 by 60, enter. Okay, now again go to move command, creates a copy and then place it. Okay, now I am reducing this into 20 mm. Again go to scale, give 20 divide by 40 because we are converting from 40 here. Okay, so here the height it is 60. From the center go to axis line, so consider 60 mm. Select the top face, using a move command select the center point and place it on the top of the axis. So place it properly. Okay, now we have to draw the slant edges. Go to straight line, select thick line and draw the slant edges. Show the angle between. Okay, convert into ISO. So you can subscribe for the channel and hit on the bell icon for the latest notification and share it to maximum students so that they can be benefited from this. Thank you for watching the video. Okay, now we move on to the next problem. So next problem it is a regular pentagonal prism of base side 30 and axis 60 mounted centrally over a cylinder block of 80 mm dia and 25 mm thickness. That means first we have to construct a cylindrical block of 80 mm diameter and 25 mm thickness. Okay, so cylinder means it will be converted into an ellipse. Here there are two ellipses we have to construct using 4 arc by center method. So take length of 80, angle 30, again length of 80, angle of 150, again length of 80, angle is 210 degree, and then join. Then use the 4 arc by center method. Draw the lines like this from the opposite end. Okay, go to arc by center and construct the arc. Okay, we will select this entire thing and we create a copy because we need to construct a cylinder. So cylinder means two circular faces were there, that means two ellipses. I'll select this and create a copy of it. I can place it separately. Now I'll be drawing the diagonal line so that I can able to place it. So here the thickness that is 25 mm. So from the center of it I'll consider the axis length for 25 mm thickness. Okay, Again go to move command, unselect creates copy, select the middle point and then place it above it. Now we have to draw two end point lines, okay, from this end. So this completes the cylinder. Now we have to construct a pentagonal prism, that is a pentagon of dimension 30. So I'll be constructing this separately. Okay, go to polygon by center and take number of sides 5 and place it with edge, give the dimension 30 and draw the box for it. Okay, separately I'm going to construct the ISO of it. Okay, and then I'm going to place it exactly at the center. That's how easily we can do it because we have the box dimensions. Okay, using that box dimensions we can do it. So here I'll consider 46.17 angle 30 degree. Again length is 48.54, angle is 150. Okay, again length is 46.17, angle is 210 degree, and then join. Go to arc by center and cut the arc for 28.53. Same way you can do it for the parallel ends, that is 28.53. we can cut it here exactly 24.27. we have to cut the arc for this edge. Here we consider 9.27 from these end points. 9.27 we can take. Now go to continuous line, thick line. Okay, select from this end point. Okay, we have constructed a pentagon. So I will draw here 3 perpendicular bisectors. Okay, to get the center of it. Now I will consider axis length from the center point. just from there for a height of 60 mm, and then centrally I'm going to copy that. Okay, this completes the problem. You can subscribe for the channel and hit on the bell icon for the latest notification, and hit on the like button and share it to the maximum students so that they can be benefited from this. Thank you for watching the video, and finally you can convert into ISO. Okay, we move on to next problem. So in the next problem, a cone of base diameter 50 and height 40 is placed centrally on top of a square slab. So in this problem we need to construct a square slab here. Okay, the dimension given 80 and height 20. That means a square box of 80 we have to construct. Take the length 80, angle 30 degree. Again take the length 80, angle is 150, and again take the length 80, angle is 210 degree. Okay, here height we should give, that is 20 mm. From the end point I'll give 20. Okay, if you find this channel really helpful, you can super like the videos. Okay, so that it is a encouragement from you people for the development of this channel. You can super like the videos. So square slab is constructed. Now above it we have to construct the cone here, cone of base diameter 50 and height 40. So separately I'll be constructing the cone here. So first I'll take the midpoint so that it will be easy for us to place it. Cone of base diameter 50. So separately I'm going to construct 50, angle 30, again length 50, angle is 150, again length is 50, angle is 210. Okay, using 4 arc by center method we construct the ellipse now. So just follow the procedure. select the middle point from it and place it. So the axis length we should consider 40 mm. Okay, now draw the straight lines tangentially touching the you can draw the lines. Okay, so this completes the problem. Now finally we are going to convert into ISO here. The top face I'll make it thick because it is a square slab. So type 0.816, so it will be converted into ISO. So this completes the problem. You can subscribe for the channel and hit on the bell icon for the latest notifications, and share it to maximum students so that they can be benefited from this. Thank you for watching the video. Thank you all, and spread it to the maximum students so that they can be benefited. Thank you all.